In this video, we will learn about Python data types. In Python, data types specify the kind of values that variables can hold. They define how the data is stored in the memory and what operations can be performed on it. Since Python is dynamically typed language, you don't need to explicitly declare the data type of a variable. It is automatically inferred based on the value assigned. Now let's see how Python automatically detects the data type of a variable. First, create a variable called var_1 and assign the value 10 to it. When I print it, I get 10, and when I check its type using type function, Python shows class int, which means it is an integer. Next, let's change the value. If I assign 10.5 to var_2, Python identify it as class float, which means it is a floating point number. If I assign some text like hello Python to var_3, the type becomes class string, representing a string. Similarly, if I assign true to var_4, Python detects it as a class bool, a boolean value. Python can also handle collections. For example, assigning 1, 2, 3, 4, 5 makes it a list, while 10, 20, 30 becomes a tuple. If I use curly braces with a key value, pairs like name, Mercy, age, 25, Python detects it as a dictionary. And if I use curly braces with unique values like 1, 2, 3, 4, 5 in curly braces, it becomes a set. So in Python, the data type of a variable is automatically decided based on the value we assign, and we can always check it using the type function. Understanding the data types in Python. In Python, everything is treated as an object. This means data types can be thought of as a classes, while variables act as instances of these classes. Python provides several commonly used built-in data types such as numeric types, examples int, float, complex; sequence data types, examples string, list, tuple, range; set data types, examples set, frozens; mapping data type, and the example is dictionary; boolean data type, example is bool; for binary data types, example are bytes, byte array, memory view; for none type, example is none type. In the following section, we will discuss these Python data types in depth using various examples. First, let's see numeric data types. Numeric data types in Python are used to represent numbers. These numbers can be expressed in different forms, such as integers, floating point numbers, or complex numbers. Python mainly provides three types of numeric data types. The first numeric data type is int, store signed integers of non-limited length. Second is float, store floating decimal points and accurate up to 15 decimal places. Third one is complex, store complex numbers. First we will see integer type. An integer is a whole number that can be positive, negative or 0 without any decimal or fractional part. Examples include 15, -7, 12, 0, -125 and 268. In Python, integers are represented by int class. Unlike some other programming languages, Python does not impose a limit on the size of integer values. The only restriction is available memory of your system. Let's look at an example to see how we can declare an integer in Python. Now let's see how integers work in Python. Start by creating few variables with integer values. For example, var_1 is equal to 16. It is a positive integer. var_2 is equal to -21. It is a negative integer. And var_3 is equal to 0. This represents 0. When I print their types using type function, Python shows class int, which means all these values are of integer type. What's interesting in Python is that it can also handle very large integers. For example, I can assign this large number to a variable and Python still considers it an integer similarly. Even if I use a huge negative number, Python identify it as an integer too. This shows Python integers are not restricted by fixed size limits like in some other programming languages. The only limit is the available memory of your system. Next is floating point. A floating point number is a numeric value that contains a decimal point or can be expressed in scientific notations. For example, 14.523, 3.14 and 1.E3. In Python, floating point numbers are represented by float class, which can store positive, negative or 0 values. The float type also supports scientific notation. For example, 1.6E4 represents 16,000. Python's float class follows IEEE 754 standard for floating point arithmetic and provides precision about 15 decimal places. Let's look at an example to see how to declare floating point numbers in Python. A float is simply a number that has a decimal point or is written in scientific notation. For example, I can write 14.523 as a float or minus 3.14 as a negative float. Even 0 can be represented as a float by writing it as a zero point 0. Python also allows floats in scientific notations. For instance, 1.5e3 means 1.5 multiplied by 10 raised to 3, which is equal to 1500. Similarly, I can write negative numbers in scientific notation such as minus 2.7e minus 4, which is equal to minus 0.00027. When I check their types using type function, Python shows class float. For all these values, Python's float type follows the IEEE 754 standard and gives us precision up to 15 decimal places, which makes it very powerful for scientific and mathematical computation. And this is the output of program. Next is complex numbers. A complex number is a number that consists of two parts, a real part and an imaginary part. It is generally written in the form of a plus bj, where a represents the real part and b represents the imaginary part, and j is the imaginary unit. In Python, j is used instead of I. In Python, the complex numbers are stored in class called complex. Let us consider an example illustrating how to declare a complex number in Python. If I write 3 plus 4j, the real part is 3 and imaginary part is 4j. Similarly, I can have minus 5 plus 2j where the real part is negative, or 7 minus 3j where the imaginary part is negative. We can also create purely imaginary numbers like 6j or purely real numbers written in complex form like 10 plus 0j. When I check their types using type function, the Python shows class complex for all of them, and this is the output of this code. This makes Python very useful for mathematical, engineering, and scientific applications where complex numbers are needed. Next is sequence data types. Sequence data types in Python are used to store multiple elements in a specific ordered manner. Python mainly provides three types of sequence data types: list, tuples, and strings. We will start with lists and then move to tuples and finally strings. Let's first see lists in Python. A list in Python is an ordered, mutable collection of elements. It can store values of different data types such as numbers, strings, or even other lists. Lists are defined using square brackets. Here I have list 1 with integers, list 2 with strings, and list 3 containing mixed values like numbers, text, and a boolean. Python even allows nested lists like list 4, which contains other lists inside it. When I check their types, Python shows class list for all of them. This makes list one of the most powerful and flexible data type in Python. Now let's see tuples in Python. A tuple is an ordered, immutable collection of elements. Tuples are defined using parentheses. Here, tuple 1 has integers, tuple 2 contains strings, tuple 3 has mixed data types, and tuple 4 is nested tuple. When we check their types, Python identifies them as class tuple. Tuples are especially useful when we want to make sure that data remains unchanged. Next one is strings in Python. A string is a sequence of characters enclosed within a single, double, or triple quotes. Strings are immutable, which means once created, their contents cannot be modified directly. Strings, for example, string 1 is a single quoted string, string 2 uses the double quotes, and string 3 is written with the triple quotes. Even though string 4 looks like a number, since it's inside quotes, Python treats it as a string. When I check their type using type function, it shows class string for all of them. Strings are one of the most commonly used data types in Python. Next up, we will see set data types in Python. A set in Python is a built-in data type that represents an unordered collection of unique elements. Sets are very useful when you need to store values without duplicates and when the order of the elements does not matter. Python provides two types of set data types. Set, a mutable meaning elements can be added or removed. Frozen set, a immutable meaning once created it cannot be modified. Let's see an example demonstrating set. Initialize this set. This is the set of integers. This is the set of strings. Duplicate values will be removed. Printing sets and their types. This is the output of the code. Notice how duplicates are automatically removed and the order is not guaranteed. Now let's see the program for frozen set. A frozen set works just like a set, but it is immutable, meaning that once created we cannot add or remove elements from it. Here frozen 1 contains integers and frozen 2 contains programming languages. Both are of type class frozen set. So remember, use a set when you need a collection of unique elements that you might want to modify, and use a frozen set when you want your collection to remain unchanged. Next up, we will see mapping data types, also called as dictionary types. In Python, the mapping data type is represented by dictionary or dict. A dictionary stores data in the form of key-value pairs where keys must be unique and immutable. Example strings, numbers, tuples. Values can be of any data type and can be duplicated. Dictionaries are unordered before Python 3.6, but from Python 3.7 onwards they maintain insertion order. Dictionaries are widely used when you want to associate one piece of data with another, such as storing student roll numbers with their names or countries with their capitals. Let's see an example declaring Python dictionaries. First, initialize dictionaries, dictionary 1, dictionary 2, dictionary 3. Now print these dictionaries and their data types. This is the output of the code. A dictionary stores values as key value pairs. Key must be unique and immutable. While values can be of any type, for example, in dictionary 1 we have personal details like name, age and city. In dictionary 2, roll numbers are mapped to student names. Notice in dictionary 3 that if duplicate key is used, Python keeps only the latest value. To access dictionary elements, we simply use the key. For instance, in the student's dictionary, we can access the name, age, and course using the square bracket notation or the get method. Dictionaries are powerful whenever we need a fast way to look up data, just like how you find meaning of a word in a real dictionary. Now let's discuss Boolean data types in Python. Booleans can hold only two values, true or false. They are often used in logical expressions and conditional statements. Interestingly, in Python, the Boolean type is a subclass of integers, where true is treated as 1 and false as 0. For example, adding true plus true results in 2, while true plus false result in 1. We frequently use booleans in conditions. For instance, if person's age is greater than or equal to 18, the boolean result will be true, meaning they are eligible to vote. This makes booleans one of the most important data types in Python, especially when making decisions in programs. Let's see some examples. Python program for declaring booleans x is equal to true, y is equal to false. Print variables and their data types. This is the output. Next, program for booleans as integers. Here we are printing the booleans as integers, and this is the sample output. Booleans in conditions. Age is equal to 18. If age is greater than or equal to 18, print eligible to vote. This is true. Else print eligible to vote. This is false. And this is the output. Now let's cover binary data types in Python. Binary data types in Python are used to store binary, that is bytes based data, rather than text. They are commonly used for handling images, files, or other raw binary streams. There are three main binary data types in Python. First one is bytes. This is immutable sequence of bytes. Each element is value between 0 and 255. Next is byte array. Mutable sequence of bytes can be modified. The last one, memory view. It provides a way to access memory of other binary objects like bytes, byte array without copying data. Let's see an example using bytes. Data equal to bytes 65, 66, 67, 68. Print bytes data and type, and this is the output. Next example using byte array. Data is equal to byte array 65, 66, 67 and 68. Print byte array data, modify a byte value, and this is the output. Next example using memory view. Memory data type, print memory view, modify data via memory view, and this is the output.